Okay, so we will start. Let us say we have one question. The question is finding out is the he has given a mild steel. Question is a mild steel, tube. Is saying there is a mild steel tube, right? Tube 4 meter long, right? 4 meter long and 30 millimeter internal dia. Let us say D1 and 4 millimeter and 4 millimeter thick. Okay, 4 millimeter thick is used as a strut. Okay, strut with both ends hinge. Right? Both ends hinged. Find the collapse load. Find the collapse load. Find the collapse load is take E equal to 2 into 10 power 5 Newton per millimeter square. Okay. So, now try to understand whether all the data is available with us or not. So, to solve the problem, what we do need is he is asking PCR, nothing but pi square EI by L square. Okay, very important. Okay, now he is asking the collapse load. Collapse means it is buckling only. Okay, so what is the data available with me? Let us first of all try to see what is the data available to me. So, E is given to me. E is equal to 2 into 10 power 5 Newton per millimeter square. Let us keep all units in Newton per millimeter square. Then what is this I? I is moment of inertia, right? Least moment of inertia, right? Is very important. I is least moment of inertia. Now, because pipe is something like this tube and it has got some thickness, right? So, this thickness is given as 4 millimeter and the internal dia is given as is 30 millimeter, right? 30 millimeter, right? Internal dia is 30 millimeter. Now, we know the moment of inertia of a tube with outer dia and inner dia, right? If internal dia 30, what is outer dia? If inner dia is this is your 30, so this thickness is equal to 4 I gave you, this side thickness is 4, so total dia will be your 30 plus 8 equal to 38. So, the moment of inertia becomes pi by 64 capital D power 4 minus small d power 4. So, capital D is your outer dia and small d is your inner dia. So, this pi by 64, capital D is your 38 power 4 minus small d is your 30 power 4. This in terms of millimeter. So, what do we get if you calculate this? 92593 millimeter power 4, right? That is one. What else we require? We need length, right? So, length is given as 4 meter, right? So, we need all parameters in millimeters. So, 4000 millimeter. Try to convert everything, right? Now, then substitute here. So, what we get here, PCR is equal to pi square, right, into E is 2 into 10 power 5, I is your 92593 millimeter per 4 by 4000 millimeter square, right. So, what I get is your 7722 Newton. So, this is PCR, this is a crippling load. You can also verify what is sigma CR. What is sigma CR? Is this load, right? This load 7722 by area, right? What is area of cross section? Pi by 4 capital D square minus small d square, is it not? Right? This is area.
Yes, sir.
So, now if I just try to solve this, how much stress I get it? 7722 by pi by 4 capital D is your 38 square minus 30 square. So, if I try to solve this, what you get is, I am trying to calculate this now, pi by 4 into 38 square minus 30 square into 7722. So, I am getting 18. I am getting, this is equal to 18 Newton per millimeter square, right. That means, try to understand 18 millimeter. So, what is this? Is definitely much less than your Fy, I mean sigma y, sorry, is it not? Because for a steel, what is sigma y? Sigma y is nothing but is your 250 Newton per millimeter square. That means, my stress is much less. So, it is buckling very early, means it must be very long, 4 meter long is too long, right. So, this part you can verify, otherwise the cross section may be too high, your yielding may be early, but anyway in this question nothing to worry, because very clearly told it is collapse. So, collapse is, we call it as only for buckling. When you say collapse, it means it is for the buckling only. Okay, is this clear? Now, the second question, a strut is 2.5 meter long. A strut is 2.5 meter long, is 60 millimeter in dia. Okay, dia. One end of that strut is fixed. One end of the strut is fixed while the other end is hinged. While other end is hinged. Very well understand. These end conditions are very important. Okay, is hinged. Find the safe compressive load for the member. Find the safe compressive load. Find the safe compressive load. Safe compressive load for the member. Using Euler's formula. He already mentioned, he is asking you to use Euler's formula. Then he said allowing factor of safety of 3.5 and take E equal to 2 into 10 power 5 Newton per millimeter square. Try understanding this. So, how to solve this problem is what we are going to see now. See, the length L equal to L is equal to 2.5 meter. So we convert into 2.5 into 1000 millimeter. It is 2500 millimeter. Okay. Now Young's modulus is given anyway in Newton per millimeter only, 2 into 10 power 5 Newton per millimeter square. Now what are the end conditions? End condition is one end is fixed, other end is hinge. So that means what is my crippling formula? PCR is equal to pi square 2 pi square EI by L square. I hope this is okay. One end is fixed, other end is hinge. So 2 pi square EI by L square, right? So L is I need to find out. So what is moment of inertia? What is this here? He has given a solid 60 millimeter dia. Okay, so that is pi by 64 d power 4. So that means pi into 60 power 4 by 64. So this happened to be your 63, 61, 72 millimeter power 4. So if I substitute all this here in this PCR, because I got length, I got moment of inertia, right? Simply substitute 2 into pi square E is 2 into 10 power 5, I is 63, 61, 72 divided by length is 2500 whole square. So this gives me a capacity of how much? 421820 Newton. That means it is around 421 kilonewton. Can anybody verify this? So we can try to see 2 into pi square into 2 power 5 into 63, 61, 72 divided by 2500 square is 401. 2 into 10 power 5. It is not exactly this much.
4,01,841.
Correct. Good. Very good. Very good. So I also verified, typed it. It's getting 401,841 Newton, right? We also call 401.841 kilonewton. Okay. So this is the crippling load. Now what is asking? He is asking, this is where it is going to cripple, or it is that it cannot carry more than that. But what is my factor of safety? Because this is the ultimate going to go. At this point, my column going to buckle. But see what is asking? He is asking me to see the safe. He is not asking me to see the compressive load. It is safe compressive. Safe means I should be safe. I cannot be in danger. So to the safe means there must be a factor of safety, right? So this factor of safety I have to use here is asking 3.5. That means we know, as from the applied mechanics, right, the safe load is nothing but the load, actual load divided by factor of safety. That is 401.841 kilonewton divided by 3.5, right? So that is nothing but is 114.8, right? 114.8 kilo Newton. Okay, this is what your safe load. Okay, so this is how we should start. So what is the change we saw? One change we saw here is the effective length factor, which is your 2, right? Because of the end conditions, 2 is added here, and moment of inertia for the solid is pi by 464 pi by 64 d power 4. That's all, right? So this is another variety of the problem. Okay, now look at just another kind of problem. If somebody may ask, find the another question I can solve is a aluminum alloy is there. Third question, an aluminum alloy has an yield strength of 40 Newton per mm square. That means Fy or stress Y equal to 40 Newton per millimeter square. That's all, very less. Aluminum. Find the minimum value of the slenderness ratio. So if this is the case, find the minimum value of slenderness ratio. Wait a minute. The slenderness ratio, minimum value of slenderness ratio for which Euler's equation can be applied. Take E equal to, that is the question, E equal to E equal to 6.7 into 10 power 4 Newton per millimeter square. Right, understand? He is saying aluminum alloy is asking what is the minimum slenderness ratio required. This is what we need to work practically in a site. In the site we need to work out this only. What is the slenderness ratio required, right? These are real time. That means I know PCR, this may what buckle. So pi square, assuming now, because assuming that it is both and hinge only, not mentioned, we are supposed to mention there, assuming it is both and hinge, pi square EI by L square, right? Because it is giving the yield stress here, I should also consider to be, I should also get in terms of stress, that is nothing but sigma CR is equal to pi square E by lambda square. Okay. So lambda is nothing but my slenderness ratio. So now he is saying that, see here what I can do actually, because slenderness ratio in the lambda L is not given, I have to assume this is what going to fail. So sigma CR is going to fail first. Okay. So I should get sigma CR is of 40 here, because very less. This is where going to fail, right? So he has already given the yielding strength of the this thing. this must be equal to sigma y, this equal to pi square E is value we can substitute the value of E equal to 6.7 into 10 power 4 divided by your lambda square. So, I can work out the lambda square, right. So, lambda equal to square root of all this pi square into 6.7 into 10 power 4, right, and this divided by 40. So, what I get lambda here is 128.6. Okay. So, lambda means your L by R, slenderness ratio is L by R. Okay. So, this is what slenderness ratio, and it does not have any units because L is in length, R is also in the length. So, ratio is unitless. So, this is how we can work out, and he is saying it is going to fail at this stress. Okay. So, I cannot find sigma here unless I got a lambda. So, I have to accept this whatever stress is given to be failing stress only. Okay. 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 So, is it okay? You understood? So, let us solve some more problem. One more last problem we can solve here. Let us say problem number what we solved, 4th, right? We solved problem 3. So, let us say solve problem number 4. A solid circular, no, we will try to take a rectangular section okay. Find the shortest length. Question is find the shortest length find the shortest length, that means length of the column we have to find out, length L for a pin ended steel column having a cross section of 60 millimeter by 100 millimeter, for which Euler formula applies, Euler's formula applies. Okay. Okay. Or take E equal to 2 into 10 power 5 Newton per millimeter square. Okay. And critical proportional limit. Critical proportional limit is 250 Newton per millimeter square. This is very clearly given to you. That means your sigma y, because for a steel this is yielding. So, you cannot go beyond this. That means that your buckling stress cannot be more than this. Very nice. Okay. So, how to solve this problem is what we should now look for. Okay. Now, so now our section is something like this. So, this is your 60, this is your 100 millimeter. So, this is in the plan, right. So, column is a column something like this. Sorry. we have got a column something like we have got a column something like this, and we have both end hinge. Both end hinge, and we apply a load. Okay. So now he is asking how much is the shortest load, shortest length. So what will be my length? What will be the length for which the your critical proportional limit is 250. So it will, I mean, it is not going to cross beyond this. Okay. So now the Euler formula, as per this, let us find out momentum inertia, and which momentum inertia? Which is least momentum inertia. How much? That is BdQ by 12. So definitely it is going to buckle in the towards the least dimension side, 60 side. So B is 100, D is your shortest, 60 Q by 12. Please do not take D is equal 100. Okay, that you will do mistake here. That means it is going to buckle with respect to the least dimension side. I told you already, like a scale, the scale is going to buckle towards the least dimension side. If you take a scale, definitely least dimension only it is going to buckle with respect to least dimension side. So that part you should not forget about it. So this equal to 18 into 10 power 5 millimeter power 4. So if this is the momentum inertia, so what is the load carrying capacity of this? P equal to pi square EI by L square, because both end hinge, pin ended, means both end pin only. Okay. So now the stress corresponding to this is nothing but, right, and if I put this in terms of stress, what I am going to write? What I am going to write? That is pi square E by I equal to, I can say this is equal to I equal to A into R square, right, radius of variation, right. So and brought that side is a stress E, right, by lambda. Okay, lambda square is equal to stress, right, P by A. So P by A is the limiting critical proportion is given. This is cannot be more than 250. So what I am going to get is a lambda square. So lambda square becomes pi square E is 2 into 10 power 5 divided by 250. Okay. So 250, is it not? How much it is?
89.
Pi square
Lambda equal to 89, sir.
10 power of 5 divided by 250. So 70, no, pi square 2 into 10 power of 5 by 250. So I am getting little lambda equal to saying, okay, fine. So 7895.7 lambda, right. So lambda equal to root of this, right, root of this, that is 7895.7 equal to, so root of this is equal to 88.85, that let us say 89, right, 88.85. So let us say 89 lambda. So what is lambda? Lambda is equal to L by R equal to 89. So that means L is equal to 89 into R. R is a what? Area into I by A, right? R is equal to I by A. Radius of variation nothing but your root over I by A. So we can find out this, that 89 into root I is what we worked out already, which is 18 into 10 power of 5, 18 into 10 power 5 by area of this is nothing but 60 into 100, right. So, this happened to be how much? This will be 1539. Let us see this into square root of
1541, sir.
18 into 10 power of 5 divided by 60 divided by 100 bracket close, this one 39 exactly 1539. Probably there is a mistake in calculation, so for you, so you can verify this is 1539 millimeter. Okay, so this is the length. So this is the length I can use if the column to be fail with the limiting of 250. So the length required is 1539, that means 1 meter, 1.539 meter. Okay, so this is how we will solve the problem. Is it clear? Okay. All safe load means we have to understand the safe load is nothing but you are divided by factor of safety. Okay. So let us I'll give one problem, little longer problem, but I'll give a try to give a idea how this problem can be solved. Let's say sixth problem. Find the ratio of strength. Find the ratio of strength of a solid circular column with that of a hollow circular column of equal area. Try to understand. I want a strength. Strength means I can say PCR for a solid circular and that to a hollow circular with the same area. Okay, the same area whose internal diameter is 2/3 of external diameter, 2/3 the external diameter, external dia. Both the columns are of the same material, right. That means both columns are same material means same Young's modulus. Both the columns of same material, right, and same material having same length, right, same length and are hinged at their ends. That means both are hinged at ends are hinged, means both the columns like this only. Okay, so I am basically I have one column like this, another column like this. Okay, so I have one column here whose is hinge, it is hinge, another column hinge, here hinge, same length, right, both end hinge, L, this also L, and if I take a cross section, one is a solid, this is complete solid, this is a hollow. Okay, both length and same material, E is same, right. and the difference is in the solid. This is a solid, this another is hollow, okay, and the P will be, we have to find out. Suppose this is, let us say, solid PS. So, this is a pH. Okay. This is going to carry some load, this is going to carry some load, same cross section area, that means this is A, this also A. Area of cross section same, length smaller same, length same, both also same hinge, right. So, this is outer dia, right, and the inner dia, let us say DI is 2/3 of DO or DE, external dia. You understood? So, now we need to find out what are the strength ratio, that means what is the P strength ratio, that means ratio of the strength of solid to the circular, that means PS by PH is our question. Try to understand, this diagram should make you everything clear. If you can draw this yourself, that means you understood the question, and you will also get a sufficient marks with this understanding. Solution is secondary, you may not get time to solve it, okay, but you have to understand this, is it not? So, now try to understand both end hinge fine. So, what is the PS pi square E I is moment of inertia of the solid by L square, right, EI by L square, L length of the solid, both are same. So, nothing to worry much, okay. So, for this hollow, pi square E of the solid and E both same material, right. So, not a problem. So, I of the hollow by L square, L of the hollow. So, both are same. So, if I take a ratio of this, what I am going to get? If PS by, I will not write here, if I want to write and then down somewhere here, PS by PH equal to, or for that matter, what is IS? Pi by 64, what? Some diameter, right? Diameter of this d power 4, right? And you look at carefully, solid, circular and this. So, solid, let us say D, right. So, what is the hollow moment of inertia? Pi by 64 capital D, I mean in this case let us say external and internal. So, d e power 4 minus d I power 4, right. So, now how to get this is what you need to be concerned about it, okay. Now, pi by 64 keep as it is. Now, d e external diameter is 2/3 of internal diameter, right. How much it is? 2/3 of, sorry, internal diameter 2/3 of external diameter. Internal diameter is 2/3 of external diameter. So, not like this here. This is, we keep it as it is, external diameter d power 4 minus 2/3 of d e whole power 4, right. So, how much we get? Pi by 64 d e can taken common, 1 minus 2 power 4, how much? 2 to the 4, 4 to the 8, 8 to the 16, 16 by 3 3 is 9, 9 3 is 27, 27 3 is 81 whole into d power 4. I mean d is nothing but my, let us say, external diameter, okay. This 81 minus 16, right. So, 81 minus 16, this is your 65 by 81. So, this is equal to pi by 64, this is 65 by 81, right, d power 4. Okay, this is what. But now I don't know the d, capital D and small d, but he has also given areas are same. So what is area of a solid? Pi by 4 d square. What is area of a hollow? Pi by 4 not cap anymore, d e external square minus d I square. Is it not? d e square minus d I square. Now again I also put the same, pi by 4 d e square minus d I means 2/3 of d, right, square. So what I get here? Let us not right now worry about this part. Okay, so how much I get? And I also want to draw a line here. This is moment of inertia working out, this is area working out. Okay, so pi by 4 d can common, so 1 minus 4 by 9 d e square. So this equal to pi by 4, 9 minus 4 is your 5 by 9 d e square. Now since areas are same, as is equal to ah, so pi by 4 d square equal to pi by 4 5 by 9 d e square. So this get cancelled, right. So d square, I have a relation here. Small d square equal to 5 by 9 small d square, and d power 4 means if squaring both sides, so what I get? D power 4 is equal to 25 by 81 d e power 4, and this I can substitute here required, right. Now what I do is your Ps by Ph is equal to solid, right, pi square E I S solid, right. Solid is how much? Pi by 64 d power 4 whole divided by pi square, I mean whole by L square is anyway there, right. Pi square E I is nothing but pi by 64, right. This here is 65 by 81 d power 4 by L square. Okay. Okay. Now this get cancelled, e get cancelled, pi by 64 get cancelled, L square get cancelled. So what I get is only d power 4 by 65 by 81 d power 4, right. Or I can directly write a numerator d power 4 means what? This I can substitute here very well. I will write d power 4 means what I got is 25 by 81 d e power 4. So this d e power 4, right. So this get cancelled out, and 81 get cancelled out. I am left with simply 25 by 65, 25 by 65, 5 5 is 25, 5 1 is 5, right, 5 3 is 15. So 5 by 13, right. So Ps by Ph equal to 5 by 13. That means almost double the solid will take, or or the solid will take half of the load. 5 by 13 is little lesser than half, same area. This gives us a feel that which, I mean, forget the answer like this, I mean, whatever that, no. So we should understand that for the same area, if there is a solid member and the same area of cross section with a hollow, right, it is taking 13 by 5, right. So 13 by 5, around 2.6 times extra load, 2.6 times, 2.6 times, right. So load equal to 2.6 times load for that of solid. So this is what you have to understand. PS by PH is equal to 5 by 13, or PH is equal to 2.6 times the PS means. Okay, thank you.